This might not be surprising, but just because someone makes a mathematical statement doesn't necessarily mean that it's true. In fact, it's our job as people that think about math to figure out if the statement is true or false, and we shouldn't believe anything just because someone said it. Let's take a look at some statements and see that, in fact, they're not necessarily true. One easy way to show a statement is not true is just to produce what's called a counterexample, a specific example which shows the statement is false. So let's take a look at this statement. Here's a statement. For all positive numbers x squared is always greater than or equal to x. Now maybe that sounds sort of true, because if you take, for example, the number 3 for x, you see 3 squared is 9, which is greater than or equal to 3. So you might say, gee, that sounds pretty good. But you've got to think about all positive numbers, and so for a counterexample, you always use red. Let's suppose that x equals the number 1/2. That's a positive number. What is x squared? Well, that equals 1/2 squared, which is 1/4. And notice that 1/4 is not greater than or equal to 1/2. So that is not true. In fact, we know that 1/4 is less than 1/2, and so x equals 1/2 provides a counterexample for this assertion. This statement is false. Here's another statement that maybe sort of sounds true at the beginning, but let's think about it. 4 points in a plane always form a quadrilateral. And quad, sounds like 4, so this sounds really good. If you take 4 points in the plane, just sort of pop them down randomly, and we connect them, doesn't it seem that they would form a quadrilateral? It looks kind of good to me. It works there. That doesn't prove it, though. And in fact, suppose the points were like this. Not just random points, but these special points. Now, when I connect them, notice what happens. I don't form a quadrilateral, I actually form a triangle. So this provides a counterexample to this statement, because I have 4 points in the plane that don't form a quadrilateral. In fact, they form a triangle. This is false as a statement. And let's try one last one. It gets hot in Texas, as you know, and the temperature in Lubbock, Texas never exceeds 107 degrees Fahrenheit during the spring months, which here we mean to be March, April, and May. Now, can we prove that statement to be false? Well, one way to provide a counterexample is to look for data. So these are the actual monthly high temperatures in degrees Fahrenheit out in Lubbock, Texas. And what do we see? Well, we're interested in March, April, and May. So we look at March, April, and May. And is it the case that the temperature never exceeds 107 degrees? Well, no, that's false, because check out May. The high temperature in May was 109 degrees Fahrenheit. So in fact, May provides a counterexample for this statement. This statement is mathematically false, and so what we now see is that this is not a mathematically true statement. So always look for counterexamples if you think a statement is not true. And if you can find a counterexample, then that statement is absolutely false. And if you can't find a counterexample, we'd still have to search for an ironclad proof before we call it true. Otherwise, it remains a conjecture. Enjoy making conjectures and trying to find counterexamples. It's probably one of the most joyful things we can do in math. I'll see you soon.